Hi, welcome to DonskyTech. In the last video, we talked about how to get started with ESP-Now in MicroPython. In this video, we will talk about the topic of using asynchronous I/O or async I/O in our MicroPython program running ESP-Now to make our IoT application more responsive.
So, this is my current setup where I have two ESP32 with multiple components connected to it. This is my sender and this is my receiver. The sender is my remote control and it controls the component on my receiver using ESP-Now. I can turn on or turn off the LED from here or adjust the brightness of my LED through PWM. I can also do it simultaneously where I can adjust the brightness of the LED and turn on and turn off the LED using ESP-Now. I can even enable or disable the whole system by clicking this button. So if I click this button and then click this button right now, then it does not turn on or turn off this LED anymore, or it does not change the LED PWM settings of this LED. So right now, if I enable it again, then I can again turn on or turn off the system or adjust the brightness or change everything at the same time. The control message is sent through ESP-Now and it uses Async I/O, asynchronous programming, to make it responsive.
This video is sponsored by PCBWay. PCBWay is a manufacturer specializing in PCB prototyping, low volume production, and PCB assembly service all under one roof.
So, what is Async I/O and how will it help us in our MicroPython programming? Async I/O is a Python library that will allow us to write asynchronous non-blocking code. To help you understand what asynchronous programming is, then let us compare it to synchronous programming using an analogy. Let's say we are a chef in a restaurant. An order came in for 3 different dishes. So let us see how will this be processed using synchronous and asynchronous programming. In asynchronous programming, the chef would cook each dish one by one. The amount of time spent is equal to the sum of each dish preparation. So if one dish equals 15 minutes, then the total would be 45 minutes. In an asynchronous way, the chef would first start with the first dish. While waiting for that dish to boil, he can start working on the second dish. And then, while waiting for the second dish also to boil, he can start working on the third dish. And then at the same time, he can switch back and forth between the three dishes. The time spent would definitely be less than doing the dishes one by one. This is asynchronous programming in action. Now, let us understand everything using code. Async I/O has three important concepts that you need to understand. First is the event loop. This is the Async I/O overall engine. The Python Async I/O event loop is typically single-threaded. This means, by default, it runs all asynchronous tasks and coroutines within that single thread. Think of this as the chef in our analogy about our restaurant who manages the cooking of our dishes. It is his job to switch working from one dish to the other. And then we have coroutines. Coroutines are special functions with the async and the await construct. Coroutines can be paused and resumed, allowing the other tasks to run in between. This is important because our event loop runs in single thread, which means that each coroutines that runs should be pausable or resumable so that we can switch between the different coroutines. Tasks. Tasks are units of work in Async I/O, and they are created or they can be created from coroutines. You create tasks so that you can schedule them to run concurrently in the event loop. To help you visualize MicroPython Async I/O, please look at the diagram below. The tasks are the coroutines that our event loop will execute, and since each task can be resumed and paused, then our event loop can schedule what task to run at a time. You will see in the code section later how we could take advantage of this in our ESP-Now MicroPython application. To know more about Python Async I/O, then you can try to follow these links. Now, let us get ready on how to use Async I/O in our MicroPython ESP-Now application by showing you how the code works.
So before we continue, I just wanted to show you the code that I have regarding the differences between using synchronous and asynchronous I/O in our MicroPython application. If you remember correctly, in the diagram earlier, we have the chef that is cooking. So I have here two example files, Python files. They are actually found in my GitHub repository. So if you wanted to take a look, then it is in the description of this video. So as you can see, this is the cook synchronous food. So in this case, we're going to use synchronous programming in cooking. So I have here a function called cook order. So in the cook order, there is it will cook the name of the dish and then the duration. So for example, the duration is how many seconds will it take for the food to be cooked. So I have here this function cook order. And then I have the function here called serve food. And I'm just going to add some timing mechanism. So we start with the timer. And then I have here the three orders that we have, which is the pasta, the pizza, and the steak. And the time it takes is, for example, the pasta will take 2 seconds, the pizza will take 4, and the steak will take 3. So if we're going to cook it in a synchronous manner, then we will start with the pasta, then the pizza, and the steak. So in this case here, as you can see, there is a order of the we're looping this list, and then we're going to call the function cook order, and then let's see what will happen. So I'm going to run it. So I'm connected to my ESP32 right now, and then let's try to, I'm just going to make this a little bit bigger, and then let's run. And as you can see, it now starts cooking in pasta. Next, it goes into the pizza, and then it waits until everything is cooked. So as you can see, in a synchronous manner, everything should be done before you could continue with the next. So for example, the pasta should be cooked before you could cook with the pizza. So as you can see, the elapsed time is almost 9 seconds. And that's because if you try to add this value here, so 2, 4, and 9, that will be equivalent to 9 seconds. So this is how the synchronous is being done. So let's try to see what will happen if we run this in an asynchronous way. So this is my code here. So as I have mentioned, we call this thing as coroutine. So in a coroutine, there is the async and then the await here. The function of the async and the await is that so that the event loop can pause or resume this particular function. Since the event loop is single threaded, so the task that it needs to execute should be pausable or resumable. So that's why we have this await option here. So it's similar. The only difference is that there is an async here. Similar also, I have here the async for the serve food. It's almost the same. The only difference that you can see in here is that we have here the order task. So this order task, what we're doing is we're going to put it in a list. And then once the function or the coroutines are in the list, then we need to call the event loop. So what I mean is we're going to create the task here from this list by using this asyncio.gather function. So anything here in the task, they will be placed in the event loop of our program. So right now, if we call await asyncio.gather, then let's see what will happen in our program. So I'm just going to clear first this one, and then let's try to run. And as you can see, the cooking starts for the pasta, the pizza, and the steak. So this is what I mean by the using of the async IO. So our program or our code just needs 4 seconds, which is almost equivalent to the highest food that we have, which is the pizza. So this is the example of how powerful async IO is in our MicroPython application. So that's basically how the difference between the synchronous and asynchronous IO. For the wiring and schematic, just follow the wiring here. So this is the schematic for the sender. So there's just three components, which is the LED control button, the potentiometer, and the enable and disable pin. So just follow along with the table here. For the potentiometer, just connect the one side to the 3.3 volts and the other to the ground. So for the receiver, just follow the same principle that we had in the earlier video. So there's the PWM LED connected to the GPIO 23, and just always connect a current limiting resistor, which is the 220 ohm. So in order for us to use async IO in our program, then we need to install the async IO version of the ESP-Now. Fortunately, there is a module called aio espnow that we can install to our ESP32 file system. So the way that you can install this aio espnow is we can use MP remote or MIP or MIP. So right now, as you can see, I'm connected to COM12 and there is no live folder currently. So I'm just going to disconnect right now. Then we can install the MP remote by using this command, pip install MP remote. And then once the MP remote is connected, then we can execute the command MP remote and then MIP install, and then the name of the module is aioespnow, and then click enter. Now it will download the library from the MicroPython live folder, and it says that it is done installing the aioespnow.mpy. If we now try to connect to our ESP32, so here, let's just connect again to our ESP32. And as you can see right now, I have the AIO ESP-Now. So if I click import AIO ESP-Now, then there should not be any issue. And as you can see, there's no problem, which means that we are ready to use the Async IO version of ESP-Now. I would like to mention that in the code that we have right now, I just use the usual handling of the button clicks, but there is a library written by Peter Hinch, and it's called the MicroPython Async. And in this library, you would find several classes that you can use in your MicroPython programming, where it is already very useful when you're using the asynchronous programming, like this push button, which you can use when you want to handle the push button switches, and it already has some API like the press function, the release function that you can use whenever you wanted to have an event handler for your button switches. But for simplicity's sake, I did not add this as the document would become a little bit bigger, and for beginners, you will have to take a good reading here because the guide by Peter Hinch contains an excellent resources for beginners to learn also. So if you're going to use this in serious MicroPython programming, then I highly suggest that you take a look at this library by Peter Hinch. So the next thing that we need to discuss is how the code works. So let's start with the sender. So I'm going to click this one. As I have mentioned, this code is available in my GitHub repository, so you can check this out at the description of this video. So let's open, and then I'm going to scan how this program works. So the very first thing is to import the necessary modules, especially the Async IO. So I have imported it here. Then we need to enable the wireless LAN, and then I can add the peer that I wanted to add in this line of code. As you can see, the ESP-Now is using the AIO ESP-Now class, which is the ESP-Now with asynchronous IO support. Next, we have this button pin, the button pin that we need to do to press and to enable or disable the LED. And I have here the potentiometer pin also and the enable and disable button. Now I have created here an event. So this event will be used for signaling. So for example, I can enable or disable this event. Whenever the event is set, then it means that the system will work. And if I clear it one, then I would disable the system. So even if I click the buttons or the potentiometer, then nothing happens. And as you can see, this is one of my coroutines. So the send button state is just pinging everything. The one thing that you need to check is this one, because I am checking the event if it is executed or not. Sorry, if it's set or not. If it's set, then I can read the value of the button. So I have just some debouncing mechanism in here. And after adding the button debouncing here, I will just send the message if it's LED on or LED off. So that's how you can send command to your receiver ESP32 through ESP-Now. For the potentiometer value, it's almost the same coroutines. So in the coroutine section, I just check also if the event is set. And then if everything is okay, I just read the value of the potentiometer. So this is the value of the potentiometer reading. And the last coroutine is the enabling and the disabling. So in the enabling and the disabling, I just if the event can be disabled or enabled. So this is how whenever something is set, can be set or not. So this is the coroutine that can respond to that button click. So as you can see that these three coroutines, they are the one that is running side by side using the event IO loop. And I have the main class here. So in the main class, I just gather everything. All of the coroutines that you're seeing here, I just added it here in the main, and I ran everything in the loop using the async io.run. So that's how you can control your different components using async io. Next, let's try to discuss the receiver. For the receiver, so this is my receiver. The code is async control receiver. So in the receiver section, it's much simpler. So we follow the same protocol. We import and then enable the wireless LAN. And then at the same time, we use the AIO ESP-Now, which is the ESP-Now with asynchronous support. And I have here the pins, the LED pin and the PWM pin. So there is a function here for the map value. This is used for the potentiometer because the value coming from the potentiometer is 0 to 4095, I think. And then we map it into the duty cycle of this PWM pin. So as you can see in the PWM pin, we just continually wait for message. If an ESP-Now message is received, and if it's LED on, then we turn on the LED. If it's off, then we turn off the LED. If it's a potentiometer message with a value, then we just extract the potentiometer value and using the duty cycle and set the duty cycle here. So basically, that's all how the code works. So whenever everything is running, or when you run these two projects side by side, then you would be able to see the output. So I'll be showing you how to run the project. So right now you only need two thonny instances to run. And the first thing that we need to do is we connect to our to our ESP32. So I'm going to connect the receiver here and the sender here also. And then at the right hand side, I will open the async control receiver.py. So this is the receiver. So it maps to this one, to my other ESP32. And the sender is the one in here. So this is the sender. So I have a cancel button here, or enable and a disable button. So to run the project, we first run the receiver. So I'm going to run. So right now, it's now running. So the next thing is we need to run the sender. So I'm going to click run here. And as you can see, everything is running now. So let's see if it... So, okay. So I have enabled the button. And then after enabling the button, let's try this one. And as you can see in the output, I was able to change the LED to turn on and turn off. And let's try the potentiometer, and let's see what will happen here. And as you can see, I can manage to change the brightness of the LED. So right now, you would notice that I can change it according to this potentiometer value. And I can also change everything at the same time. So I can click this on, and then at the same time, my program is still very responsive. So right now, I can read two sensors in my circuit. And as you can see, I can turn on and change the PWM at the same time. So after which, then we can have this button, which is the enable, and let's try disabling. And as you can see, there's a message that it is clicked. And even if I uncheck it, click this one and change the potentiometer, nothing is happening anymore. So I'm going to re-enable again by clicking this button. And then after enabling, I am able to change everything or adjust the PWM settings. So that's it. And that's it. So in this video, I have shown you how you can run your ESP-Now MicroPython projects with the Async IO support. The write-up for this project is available at the description of this video, and also the code available in my GitHub repository, so you can learn and check it out. As usual, if you have any comment or suggestion, then please write it here. And I hope you could subscribe to my channel so that you could support me in doing this project. That's all. I hope you learned something. Happy exploring!